Alright, last but not least, our 1.4 part 3 video going through the last page of 1.4. So you can flip to that one. Hopefully you tried out the word problem and you finished up the relative max and min. So I'm here to help you check your word problem or walk you through if you're stuck. And I'm going to take it nice and slow. Now I don't have the calculator up here, so you're going to have to use your calculator to help you with this problem as we go through. So I highlighted right now the function here. We want to find out, our goal is the x and the y values of the max point. And if we read through, they tell us that this equation gives us the miles per tank of gas in a car, where x is some speed. So we want to know what speed optimizes the distance the car can travel. Right, so what speed is the best? What speed is going to give you the most mileage in the tank? So if we had this graph, we're looking for the highest point on the graph. So the first thing we're going to do is we're just going to put that function into our calculator. So I'll give you a second if you haven't yet. Actually, you can pause the video. I'm going to keep going. So throw that into your calculator, and then again, we're thinking about these values. So when you put that in the calculator, you're probably not going to get a nice window, right? Especially if it's already set to the standard window. That's a 10 by 10. So think about our x and y values. And then I would manually set the window, just like I did in our relative min-max video. Otherwise, you're going to hit the window button. And now let's think what x values would make sense, right? So I went a little too fast. I'm going to go back. Right? The x values are miles per hour. So we definitely don't need negatives, right? We can start at 0 miles per hour, and we want to give ourselves a little buffer room. So, I don't know, normal highway speed like 55, 65. Probably people go upwards of 70, 80, or 90, even though that might not be allowed. So let's give yourself anywhere, from 90 to, I'm going to go really vague here and give myself a lot of room on the graph, maybe 120, but that should be plenty of room. So in my window, I'm going to set the x min as 0, the x max is 120. And those are the values that I just wrote over here. So that would be my min, that would be my max. All right, same idea for the y. So we want to think about what makes sense for miles per tank of gas. Now, a lot of you probably aren't driving yet, but definitely 0 to start off. And then just kind of pick anything. Think about how many miles either your parents drive in your car before they need to get gas, little things like that. And I don't know, I don't have a good estimation here, but maybe 5 minutes in the car, in Montgomery would be just 2 or 3 or so miles. So think about how long they can go without getting gas. My car's pretty new, so I get between like 350 and 450 depending on how fast I go and highways versus back roads. So I'm going to go right in the middle there. I'm going to go 400 for miles per tank of gas. And this is just a start off point. If we can't see a lot of the graph, then we're going to try again. Alright, so once we have our graph, we're looking for a local max or a max point on our graph. So I put it in my calculator, and I went to calculate my max, adjusted the screen just like we did on the page before, and it worked out that I found the point 70 for my x max, and the y value there was 362.5. So that 70 miles per hour is our optimum speed, and that would result in the car traveling 362.5 miles in our tank. Alright, so I'm going to leave this page. If you need help, come find me on that one. We'll probably see a couple more problems like this in our homework or practice problems that you guys are trying out. So you can go ahead and try those out, or continue. I'm going to go to the next slide for that last piece on our 1.4 packet, which is the average rate of change. So I'm jumping all the way down to the bottom. I only need those 2 practice problems, but read through the average rate of change little blurb there. It says for nonlinear functions, the slope changes between 2 points, right? Like really any function. And when it changes, we make this our average rate of change, and really it's just an average slope. So we're going to be finding the slope between 2 points, even though it's not or may not be a linear equation, right? That would be the average rate of change. So about how quickly things are changing. And you guys will see down here, this equation is really just our slope equation. Up top, we have the change in y values, right, f of x, and in the denominator, we have the change in x values. And I hope I said that right? Change in y over change in x is our slope. So we're going to go to the first problem. You guys can try these out on your own if you want, and then just skip to the end and check your answers. Now what they give us is an interval. So the x values, like we would domain or domain for our x values, so that -3 is our x1 and the -1 is our x2. And that's if we were thinking about looking at a graph, right, where we would be starting. So we'd be starting at -3, ending at -1. Like up top, right, those would be the starting and ending values. So now we're just in the negative portion of our graph. So I'm going to take those values, and that would be my denominator, but we need to find our f of x1 and f of x2. And we're just going to do that by throwing those in the equation. So I'm going to put -3 in for x and simplify. So take a minute to do that if you need to. Then you can double check with my answer. And I'm going to do the same thing for -1. So I'm going to put that in the equation and simplify again. Okay, and then the last step is to use those values in our fraction. So in the numerator, we're going to have the change in y. So I just wrote here AROC, average rate of change. So our numerator is the change in y, which is going to be our f of x2, right, which we found above. So I'm taking the 0 and the 24 over the change in x values. And I'm going to write over my arrows there, but works out to be 24 over 2, which simplifies all the way to 12. So that's all we have for these, just a number as our answer. So the average rate of change for this problem would be 12. And think about what that is. It's an average slope. So for this graph, if we graph that function, -2x squared plus 4x plus 6, right, on this interval, it'd be a positive average slope. So we'd know over there that it's an increasing interval. Alright, so try out letter B here. I'm just going to write through. So if you want to double check, I'm not going to go as in-depth as letter A there, but I'll let my writing run, and then check out that your answer agrees with mine at the end. Okay guys, that's it for my 1.4 videos. So go ahead, run through your homework, try out anything. If you have any extra questions, feel free to come ask me, or go back to these videos and see if you can get your question answered. Hope you enjoyed it, and let me know if you see anything I need to fix or anything I can improve. Alright, good luck.